Hello friends and welcome to a lecture on operation research. Today we'll be looking into a queuing problem. This is Professor Arvind Prasad. So let's have a look at the problem now. A warehouse has only one loading dock manned by a three-person crew. Trucks arrive at the loading dock at an average rate of 4 trucks per hour and the arrival rate is Poisson distributed. The loading of a truck takes 10 minutes on an average and can be assumed to be exponentially distributed. The operating cost of a truck is rupees 20 per hour and the members of the loading crew are paid rupees 6 per hour. Would you advise the truck owner to add another crew of 3 persons? So let's have a look at how do we solve it. Now this problem is of the queuing model M/M/1 infinity FCFS, where M stands for the Markovian distribution of the arrival time and the next M stands for Markovian distribution of the service time. 1 stands for the number of servers, infinity stands for the capacity of the server, and FCFS is the queue discipline, where FCFS is short for first come, first serve. Now, as we can see here, there is only one warehouse, so therefore the warehouse is the server and we have only one server. The arrival rate, of course, is Poisson distributed, so it's a Markovian distribution. The service rate, that is the truck loading rate, is exponentially distributed. The time is exponentially distributed, so it is also a Markovian distribution. Now, why do we take the server capacity as infinity? Here we know that the arrival rate of trucks is going to be 4 trucks in an hour. And the warehouse has a sufficient capacity to accommodate this load of arrival. Therefore, we assume that it has an infinite capacity. So if the capacity of the server, the capacity of the queue is such that it can accommodate all the arrivals, then we take the capacity as infinity. So let's go on with calculation of cost per hour. So the cost per hour is going to be cost of waiting for trucks plus cost of loading. I need to give you a hint here. The loaders should load all the trucks they get in an hour. Whether in an hour when the loading of the truck comes over, in an hour whether they have to load one truck or two truck, they have to load it. Okay. If it takes half an hour, for example, let's say if it takes half an hour to load a truck and in an hour they can load two trucks, so they have to load both the trucks. Now they are paid on hourly basis. They are not paid per truck basis. This is what we need to understand here. So the cost per hour is going to be rupees 20, which is nothing but the cost of waiting time for a truck multiplied by 4 over 6 minus 4, which is nothing but lambda over mu minus lambda, which is nothing but number of trucks in the system, plus rupees 6 into 3 because we have 3 members in a crew. So that's going to be 6 rupees per member and that's 6 into 3. So the total cost comes up to rupees 58. Now with the addition of one crew, twice the number of trucks could be loaded. That's a fact because we have doubled the crew now. Okay, so the cost per hour is now going to be 20 into 4 over 12 minus 4 because now the loading rate goes from 6 per hour to 12 per hour. So it's going to be 4 over 12 minus 4 plus rupees 6 into 6. That is because we have 6 crew members now and that total is going to come to 46. So the example shows what is the reduction in cost if more loaders are employed. And why does this happen? It happens because it reduces the truck's waiting time. And that is why there is a reduction in cost per hour. So this example demonstrates that if we reduce the waiting time by increasing the manpower in servicing things, we could profit from the situation. So that was all about a problem of this problem. If you like this video, do subscribe my channel and do share this video with others who would be interested and ask them to subscribe it. Goodbye friends. Have a great time.